Hi, I'm Cynthia, along with Mark and Shelley from the Center for Mathematics and Teaching. Thank you for joining us today for our webinar on geometry. We are in the process of getting out our second edition of middle school core courses and are really proud of so many of the lessons we've put together. We're happy to share some of them with you today, so let's get started looking at some great lessons for middle school geometry. As our goals today, we're going to focus on some important middle school geometry standards from interesting, engaging lessons. After seeing them, we think you'll want to try them in your schools. The ideas we'll be sharing with you today are taken from the second edition of MathLinks. Here you see 3 units per grade level that are ready to try. We call each of these units a packet because they are offered in a consumable packet format. You'll see that they are so much more than what people think of as a workbook. Stay tuned for examples. The full 10 packet course will be available for use this upcoming school year. Here are the packets we shared in a webinar a few weeks back. These are all about using multiple representations to gather data in tables, make graphs, and write equations, sort of the basics of linear equations relevant to grades 6, 7, and 8. Those webinars are available to view on our website, and you can try those as well, and we'll show you how to do that in a bit. These packets address most of our middle school statistics and probability standards. You can also find the recording of that webinar on our website. And here are the 3 geometry packets that we're looking at today. Remember that our new MathLinks programs are complete, cohesive core programs that are student and teacher friendly and efficient to use. Here you see the scope and sequence for 6th grade. The lessons in just 10 student packets allow you to address all grade level standards in only 100 class hours, leaving plenty of time to do other important work. Here is packet 1 and packet 7 that have been discussed in previous webinars, and packet 9, which we're looking at today. Here is the 7th grade course with packet 1 and 3 that have been discussed previously, and packet 9 that we're experiencing today. And finally, here is the 8th grade course with packets 4 and 6, which we've seen previously, and packet 1, which we're looking at today. Remember that all 9 of these packets are available to pilot. This is what a cover of each student packet looks like and what you'll receive when you pilot our program. All right, let's begin with 6th grade geometry pilot packet. Mark, take it away.
Thanks, Cynthia. We're going to look at some highlights from the opening problem and lesson 1. Pay close attention to how we pose a problem to create a need to know, teach some concepts and skills, and then come back to the problem to finish it up. This happens frequently throughout a MathLinks course. These oddly shaped rugs are flashed on the screen, and students commit to which one they think is bigger. They should be given time to discuss, argue, and critique each other's reasoning. What does bigger mean? Taller? Wider? We eventually land on the concept of area so that the more precise question is, which rug has the greater area? Students might explore by counting and estimating numbers of squares, but here in 6th grade, students probably don't have the prerequisite skills to find these areas because the only figures they've had to find areas of in elementary school were rectangles. That opening activity may run about a class hour or so. And in the ensuing days, students take a deep dive into learning the formulas to find the areas of parallelograms, triangles, and trapezoids. You should know that in MathLinks, we always make formulas, rules, and algorithms plausible for students. Visuals, manipulatives, and other sense-making strategies are used to lead students to understanding. Conceptual development is always at the forefront of what we do. Before we get back to solving the opening problem, there's plenty of time for skills practice. But in addition to typical practice pages, we love to infuse our packets with games and puzzles for practice as well. Remember, I'm not showing you everything in this multi-hour lesson, just some highlights. Here, you see some ordered pairs that when graphed, looks like this. Students cut apart their tangram pieces and are challenged to make various figures with them. Then they get to find lots of areas. After all this concept development and practice, we're ready to go back and tackle the opening problem to verify which rug actually has the greater area. There's so much more going on in the packet with surface area and volume, and you can experience it all at your own pace another time. And now on to the 7th grade geometry pilot packet. Similarly, we're going to see an opening problem that students can explore, but probably can't complete. Then go on to developing a concept and some skills, and then come back to the problem to finish it off. Here's a great problem about Felix the sheep. Clearly, we don't have enough information to answer this question. So we ask some standard questions to get students thinking. Here, we highly encourage teachers to chart what students share with the entire class to keep the discussion going and to pique an interest and curiosity. We reveal some important information, and when students see numbered problems in this blue color, it's a sign to start writing. By the way, all slide decks provided for instruction have concise notes for the teacher. They're not a script, but provide guidance on how to pace this part of the lesson and offer some good questions we think should be asked. Additionally, if you prefer some other delivery method than a slide deck, this alternative page is provided to use on a DotCam or for writing on a whiteboard or using a smartboard or whatever your preferred style is. In lesson 1, we investigate circle circumference, arrive at a formula, and do some problem solving and skills practice. But what I really want to show you is lesson 2, where we move to circle area, following the same principle of developing concepts first to create meaning. Here, we start the process of leading students to find the area of the circle formula. Watch it play out as we cut a circle into multiple wedges. We suggest that half the class make 8 wedges and the other half of the class make 16 wedges for contrast and comparison. We continue by cutting out the wedges and putting them together like this. And as students create these parallelogram-like figures, we move on and tie it all up here by relating properties of a parallelogram to the circular parts that we're now wrangling with. And then we arrive at the circle area formula. Here's an example of just some of the practice. And notice that we make sure that students go back to finishing the opening problem now that they have the skills. And we love to make connections. Here's an interesting page that connects area to probability. And you also see a reference to the MathLinks rubric that we created. With teacher facilitation and guidance, students are encouraged to either self-assess or peer assess as they get used to the rubric throughout the year. This is a great example of formative assessment as students sharpen their problem-solving skills. Why wait until performance tasks arise on high-stakes tests to practice this important work and give students opportunities for growth? Later, we'll point out that there are tasks that go along with every packet that could be used with the rubric as more summative assessments. And again, there's plenty more for you to review in this packet at your leisure another time. Okay, now on to 8th grade. Let's once again jump into an opening problem that students can wrestle with and then revisit later after they've learned some concepts and skills in lesson 1. 3 regular pieces of paper set the stage for this investigation. These rolled up tubes, as we call them, really aren't solid figures because they're missing their bases, but they'll do the trick. Here are the 3 tubes that we make. Notice that they all have the 8.5-inch edge of the paper as their height. We make sure that students understand that these aren't really solids, but resemble them. Sketches are drawn. And then we start to make some predictions or conjectures. Now it's time to write and use formulas. Rectangular and triangular prisms came up in previous grades, so this is a good formative assessment to check retention. Some reteaching may be necessary. That being said, it's conceivable that students do remember the process for finding volume of the first 2, and they may intuitively extend that prior knowledge to finding the volume of a cylinder. Though it's not expected, I think that would be great. As we jump into lesson 1, we try to access some prior knowledge and begin to make connections. And we continue making those connections here. And then we finish up here to establish a reasonable formula for the volume of a cylinder. And as we do in every packet, we make sure students have plenty of opportunities to make mathematical arguments and to critique reasoning. And as always, practice follows the concept development. And then we go back to the opening problem to finish the work we started. And we also extend it now by using the 11-inch edge of the paper as the tube heights. Whenever we share our lesson ideas and the simple, effective format we use, people really seem to like what they see. And we hope you do too. Okay, back to you, Cynthia.
Thank you, Mark. So if you're ready to look further, go to our website that you see here, mathandteaching.org, and find the curriculum tab, where you'll see our new core 2nd edition. And then you can find a place that gives you all you need to know about piloting one of our geometry packets you experienced here, or any of our 9 packets that are ready for piloting. If you're not quite ready to pilot, this will take you to a place where you could preview 3 packets, 1 from each grade level, which allows you to view the whole packet and even try some of it. When you do choose to pilot, here's what you'll get: a class set of consumable student packets, access to all teacher materials, and virtual support from one of us to get you started and work with you as needed. We're going to skip this slide. Now, let's move on to some student packet features. Focusing on vocabulary is important in learning mathematics. Every packet begins with a word bank, and vocabulary comes up in context. Teachers facilitate student discussions so that they can include meaningful examples and explanations in their own words. In the review section is a vocabulary activity for practice. At the very end of the packet are precise definitions and explanations and examples that students and those who might be helping at home can refer to. The review section has 3 pages of review activities, many of which are best done with partners. The example shown here is a poster problem. Students work on a variety of related problems as they travel from poster to poster with their group. One of these is in every packet because they have been so popular with our teachers and students over the years. Every packet has a few spiral review pages, so students strategically revisit important topics from previous packets throughout the year. And here is another example of a problem page, which includes the MathLinks rubric that Mark talked about earlier. This rubric allows for students to focus on a particular part of a task page and self-reflect or reflect with a peer so that they grow on whatever areas of problem solving are needed. And speaking of reflection, at the end of every packet is a page dedicated to reflecting on the content and mathematical practices of the packet. At the top, you see the 7th grade Big Idea wheel. In the geometry packet, 6 of the 7 big ideas in the grade are at least partially addressed, with many connections made between them. Along the way, we prompt teachers to consider particular problems suited for journaling, and at the end of every lesson, we ask students to go back to the packet cover and score themselves on a scale of 0 to 3 on what they've learned. Now for a quick overview of some other teacher resources. We know that assessment is important, so we want to provide several options for multiple measures with which to assess students both formatively and summatively. Here you see a wide variety of what we consider to be formative assessment, many within the student packet. And here you see what are more commonly considered summative assessments. Lots of variety and lots of choice. And of course, there are a wide range of needs for different learners. While we can't possibly begin to address every possible learning difference, we do provide many ongoing opportunities for differentiation. These features that are based on intervention research address the needs of struggling learners and give them a better shot at doing grade level work. All students deserve opportunities to show what they can do, so these features are meant for all students. Know that when some students are working on catching up, some of these features are great for other students who are ready for enrichment. Here's a close-up view of our grade 8 Big Idea wheel that's in the teacher edition. We are convinced that teaching with an eye on big ideas allows for more connections to be made and more efficient and effective learning. Here's an example of the benefits of making connections using big ideas. Since the lessons in the 10 packets are designed to address all grade level standards in about 100 class hours, we know that the remaining time can be split up with extra practice, intervention, enrichment, assessment, all of which are right at your fingertips. Thanks so much for being with us today. Make sure you go to our website and check out the information regarding our core 2nd edition or any of the pilot information you need. Feel free to reach out to any of us via email with any questions, and thank you for attending.